Hello, Vanakkam. I am Sujit. Welcome to Physics 2020. So today in this session we are going to discuss relative velocity in two dimension. So before coming to this topic, first learn that is relative velocity in one dimension. So in Physics 2020 I have posted that is 3 videos, that is relative velocity in one dimension, one conceptual video and 2 problem solving videos. Okay, so please go back and watch that video, try to understand the concept of that is relative velocity in one dimension, then only you can easily understand that is relative velocity in 2 dimension. Okay, so why we are studying that is relative velocity in 2 dimension means in physics, in JEE mains and Neet, there will be some problems regarding that is rainman problem or umbrella man problem, umbrella rain problem and a river board problem. Okay, river board problem. So these problems are the application side of this relative velocity in 2 dimension. Okay, relative velocity in 2 dimension. So just we are discussing the concept of that is relative velocity in 2 dimension. We will discuss the problems. Okay, rainman problems and boat river problems. Okay, so let us learn. So relative velocity. Relative velocity in 2 dimension, 2D. Okay, so just to recollect what we have studied in that is relative velocity in 1 dimension. Okay, 1 dimension. Suppose an object A is moving with velocity that is VA. Okay, so the correct way of writing that is velocity VA with respect to ground. Okay, with respect to ground. So ground is the frame of reference. Okay, ground is the frame of reference. That means the observer is at the ground. So what is frame of reference? What is the role of this frame of reference in that is relative velocity? How this frame of reference changes from one to another? Okay, so these are the things we have discussed in that video, that is relative velocity in 1 dimension. Very thoroughly discussed that is these things. So if you want to understand the basic concepts of that is relative velocity in 1 dimension, go back and watch that video and come back. Okay, so VAG, that is the observer is at the ground. So this is the ground. So this is the ground, an observer is here. An observer is here. So when he watches that is the object A, it is moving with that is velocity VAG. So another object is here. So object B. So it is moving with velocity that is VB vector. VB vector. So the correct way of writing that is VBG. Okay, VBG. Velocity of B with respect to ground. So then relative velocity of A. Relative velocity of A with respect to B. With respect to B. So now that is the observer is initially the observer is at the ground. So the velocity of A with respect to B, or we can say that the velocity of A as seen by B. So that means the observer changes its position from ground to B. The observer is up to object B and he is watching. Okay, he is watching, that is A. So that is the meaning, that is the relative velocity of A with respect to B, or we can say that velocity of A as seen by B. So we can write that is velocity of A with respect to B vector is equal to VAG minus VB bg. Okay, so this is the formula. This is the formula for, that is the relative velocity of A with respect to B. So similarly, relative velocity of B with respect to A, So the observer changes its position from B to A. So the observer changes its position from B to A. So the observer is in object A and he is watching B. That is the meaning. So we can write that is velocity of B with respect to A. Okay. So that's equal to VBG minus VAG. Okay, so this is the formula to find, that is relative velocity of A with respect to B and relative velocity of B with respect to A. So these are the basic things of, that is relative velocity, which we have discussed in the that is relative velocity in one dimension. Okay, one dimension. So what is relative velocity in two dimension? Okay, relative velocity in two dimension. Suppose V VAG, okay, VAG and VBG vector are the velocities of two bodies. So two bodies which are inclined at an angle theta. Which are inclined at an angle theta. So in the initial case, that is the objects are moving in a straight line. That is the relative velocity in one dimension. The objects are moving in a straight line. So here, that is two dimension means, that is the two velocities are inclined at an angle theta. It is like this. It is V AG vector and V BG vector. So they are inclined at an angle theta. So what is relative velocity V? Okay. So V AB. Okay, V AB. So they are not in straight line. So they are inclined at an angle theta. So VAB is equal to, so the first formula only, that is VAG with respect to ground minus VBG with respect to ground. So we can write that is VAG vector plus minus of VBG. Okay. So that is two vectors, okay, which are inclined at an angle theta. So how to find the resultant? So this is the resultant vector. Okay, this is the resultant vector. So how to find? Suppose two vectors are inclined and at an angle theta. So how to find the resultant? That is equal to root of V AG square plus V BG square plus 2 V AG 2 V BG cos theta. cos theta. So this is the formula to find. So here minus, because VBG is minus. So minus VAG VBG cos theta. So this formula can be used to find the resultant vector in 2 dimension. Suppose the two vectors are inclined at an angle 90 degree. So we will get that is equal to root of. So cos theta, cos 90, 0. So this term becomes 0. Okay, so we will get that is VAG square plus VBG square. So this formula we can use to find the resultant velocity. Clear? So what is the direction of the resultant vector? So the resultant vector means that is velocity of A with respect to B. That is the resultant. Okay, so what is the direction of the resultant? So resultant can be find, which is using the formula tan theta is equal to B cos theta divided by A plus B. So B sin theta divided by A plus B cos theta. So tan theta is equal to V BG sin theta divided by A minus B, that is VAG minus, here minus, okay, because it's minus. So VAG minus VBG cos theta. So this formula you can use to find the direction, okay, direction. Okay, direction. Tan theta is equal to VBG sin theta divided by VAG minus VBG cos theta. So clear? So these are the theories or concept regarding the relative velocity in 2 dimension. So Rainman or rain woman or rain umbrella problem. Umbrella problem. So these are the problems we can expect in that is relative velocity in 2 dimension. Okay, Rainman or rain woman or rain umbrella problems. Okay, so first problem, very simple problem, first problem. Okay, so the rain is falling vertically downwards with velocity 40 km per hour. 40 km per hour. So man is standing in the ground at rest. Okay, at rest. So the man is at rest. Rest. So the rain is falling vertically downwards with a speed that is 40 km per hour. So man is standing in the ground at rest. Okay, at rest. So we have to find 2 things. First thing, what is the velocity of the rain? Velocity of the rain with respect to man, or what is the relative velocity of the rain with respect to man. Second one, in which direction the man should hold the umbrella to protect from the rain. Okay, so these are the 2 things we have to find. So the rain is falling vertically downwards with the speed of, that is with the velocity of 40 km per hour. That is velocity of the rain with respect to ground is equal to 40. So it is falling vertically downwards. So 40 minus 40 j cap. Minus 40 j cap. Downwards. That is negative y direction. Okay. So velocity of the man with respect to ground is equal to 0. Okay, 0. So we have to find, that is, what is the velocity of the rain with respect to man. Velocity of the, what is the velocity of the rain with respect to man. So velocity of rain with respect to man is equal to, that is the relative velocity of the formula we have studied. Okay. So velocity of rain with respect to ground minus velocity of man with respect to ground. So that's equal to velocity of rain with respect to ground, that is minus 40 j cap minus velocity of the man with respect to ground, that is 0. So that's equal to minus 40 j cap. That is the answer. What is the velocity of the rain with respect to man? Okay. So velocity of the rain with respect to man is equal to, that is minus 40 j cap. Okay. So second question, in which direction the man should hold the umbrella to protect from the rain? So this is x-axis and y-axis. Okay. So what is velocity of the rain with respect to man? So we have to find the direction of the rain. Okay. So velocity of the rain as seen by the man. Okay. Velocity of the rain as seen by the man. So that is minus 40 j cap. So it is in this direction. Okay. Negative j cap is the unit vector of, that is negative y-axis. So 40. Okay. 40. The speed of 40. So the man sees the rain. It is falling vertically downwards. Okay. Vertically downwards. Vertically downwards. So according to the man, he finds that, that is, or he feels that the rain is falling vertically downwards. So in which direction he should hold the umbrella? He should hold the umbrella like this. Okay, he should hold the umbrella like this. So the rain is falling with the speed of, that is 40 kilometer per hour. Okay, 40 kilometer hour, that is vertically downwards. So he should hold the umbrella like this. So he should hold the umbrella like this. So that is the direction. Because the velocity of the rain, okay, velocity of the rain on the direction of the rain as seen by the man is, that is vertically downwards. That is minus 40 j cap. Okay, minus 40 j cap. So minus j cap is the unit vector in the negative y-axis. Okay, negative y-axis. So we can plot the rain, the direction, we can plot the direction of the rain in the negative y-axis. Okay, so we have to, that is, hold the umbrella in this direction to protect himself from the rain. Clear? So second question. So the rain is falling vertically downwards with a speed of, that is 40 kilometer per hour. 40 kilometer per hour. A man is riding the cycle. Okay. So man is riding the cycle with a speed of that is 30 kilometer per hour. 30 kilometer per hour. Okay. So our question is, so understand the question, the rain is falling vertically downwards with a speed of 40 kilometer per hour. So man is riding the cycle. Okay. Man is riding the cycle with a speed of 30 kilometer per hour in the rightward direction. Okay, rightward direction. So our question is, what is the velocity of the rain? First question. Velocity of rain with respect to man. With respect to man. First question. Second question. In which direction he should hold the umbrella to protect from the rain. To protect from the rain. Okay, so understand the question, that is rain is falling vertically downwards with a speed of 40 km per hour. So a man is riding the bicycle with a speed of 30 km per hour in the rightward direction. So, okay, so we have to find the velocity of the rain with respect to man. In which direction he should hold the umbrella to protect from the rain. So, so he has to, that is, rain is falling vertically downwards. But when we ride the bicycle or bike, that is, we usually feel that. When we stop the bike, so the rain is falling. And when we stop the bike, we feel that the rain is falling, that is, the rain is hitting our head. So when we ride the bike, we usually feel that is, the rain is hitting in our face. So we have the feeling that the rain is coming in this direction. Okay. So normally when we stop the bike, that is, the rain is falling, that is, vertically downwards and hitting our head. Okay, hitting our head. So when we ride the bike, we feel that the rain is coming in this direction, okay, in this direction, and hitting in our face. So it is because of the relative velocity, okay, relative velocity of that is man and rain. So when we ride the bike, when we stop the bike, that is, we usually hold the umbrella like this. Okay, so when we ride the bike, we have to hold the umbrella in a certain angle, okay, certain angle. So we have to tilt our umbrella to the forward direction, okay, certain angle to the forward direction. So that we have to find in which direction, because the man is riding the bicycle 30 km per hour. So in which direction he should hold the umbrella to protect from the rain. Okay? That is the second question. Okay. So solution, come on. So velocity of the rain with respect to the ground, that is 40 kilometer vertically downwards, that is negative y-axis, 40 minus 40 j cap. So velocity of the man with respect to ground, it is moving rightward direction, that is positive x-axis. So that's equal to 30 I cap. Okay, 30 I cap. Correct. So we have to find the first question, velocity of the rain with respect to the man. Velocity of rain with respect to man is equal to formula, that is relative velocity formula, that is velocity of rain with respect to ground minus velocity of man with respect to ground. Okay. So that's equal to, what is velocity of rain with respect to ground? That is minus 40 j cap minus velocity of man with respect to ground, that is 30 I cap. So this is the answer for, that is velocity of rain with respect to man. This answer for first question. Okay, first question. Velocity of rain with respect to man. Okay. So the second question, in which direction he should hold? That is because the rain, normally for a standing man, the man at rest in the ground, he feels that the rain is coming, that is in the downward direction. The rain has only one velocity. So when for a moving man, okay, so the man in the bicycle feels that the rain has two velocity. One velocity in the downward direction and another one velocity in the negative y-axis. Okay, negative y-axis. Okay, so some of the rain is falling. Okay, some of the rain is falling, that is in the vertical direction. So, and another velocity in the negative y-axis. So the combined, so the rain has two velocity. For a moving man, the rain has two velocity. One velocity in the negative y-axis and another one velocity is in the negative x-axis. Okay. So minus 40 j cap. So in this direction 40 minus 30 I cap. In this direction, that is negative y-axis, that is 30. Okay. So two vectors. This is one vector and another one vector. Okay. For a moving man, the rain has two velocity. So one velocity in the negative y-axis and another one velocity in the negative x-axis. Okay. So according to that is parallelogram law of vectors. Two vectors. Okay, two vectors. So according to parallelogram law of vectors, what is the direction of the resultant vector? So the resultant vector is acting in this direction. Am I right? In this direction. Which makes an angle theta. Okay, which makes an angle theta. So for a moving man, so the resultant velocity or the direction of the resultant rain is in this direction. Okay, in this direction. Okay, so he feels that the rain is coming. So for a moving man, he feels that the rain is coming in this direction. So if this angle is theta, means this angle is also theta. Okay, theta. So he should hold the umbrella in this direction. In this direction. Okay. So the rain is coming. He feels that is the rain is coming in this direction. So which makes an angle theta with the perpendicular. Okay, perpendicular. So he should hold the umbrella like this. Okay, like this. Negative direction. So we have to find, that is, what is the exact angle. So that is parallelogram law of vectors. Okay, parallelogram law of vectors. That is, we have to find, that is tan theta. Okay, tan theta is equal to 30 divided by 40. So that's equal to tan theta is equal to 3 by 4. Okay, 3 by 4. 3 by 4 is a famous triangle. That is, so this angle is theta. Okay, so 3, 4, 5. Okay, 3, 4, 5. So what is the angle? That is 37 degree. Okay, 37 degree. 3, 4, 5. 37 degree. So tan theta is equal to 37 degree. It is equal to opposite side by adjacent side. So 3 by 4. So theta is equal to, here tan theta is equal to 3 by 4. So theta is equal to 37 degree. Okay, so 37 degree. So what is the answer? Second question. In which direction he should hold the umbrella to protect from the rain? So he should hold the umbrella 37 degree. Okay, 37 degree from the vertical. Okay, 37 degree from the vertical. So the cyclist, okay, the man in the cycle should hold the umbrella that is 37 degree. Okay, so suppose this is the vertical, so 37 degree. Okay, 37 degree from the vertical. So when he is at rest, when he is standing in the ground, he has to hold the umbrella like this. When he is moving in the cycle, he has to hold the umbrella like this. So 37 degree. Clear?